All right, thank you so much for that, Victoria. And yeah, we're definitely gonna remember your name for reminding me multiple times to record the videos. I don't want to post some video like last only a few minutes, like at the end of the day, and then you have all the lectures now being recorded. That's gonna be very embarrassing moment. And it was a long time ago. It was like a week ago. Yeah, well, I mean, I think that you absent on Wednesday, something like that. It was pretty tragic, to be completely honest. My dog just keep walking, and some of my friends just like threw me off the water, something like that. And then my kids also keep crying. You might hear his noises along the way. It's yeah. Uh, do you think you could go over the second questions of the classwork? Yeah, it was. Yeah, I got sick on that day, so I couldn't really wake up on on Tuesday, and it was really awesome because I think I would be able to cancel the class. What's the reason? Oh, I was kidding. So my wife woke me up and gave me like a glass of milk, and then after that, I would be able to go to the class, just sort of like, talk to my people, my birthday things, some balloon things, some cakes, and then some food, and that's pretty much the whole day. That's pretty awesome because at least I can have something to talk to my students. So that's really amazing. And out of that, I give out some homework problems. The best thing yeah, to teach the course is like everybody knows the material. Just give out the homework, and people really happy to walk out of the classroom. And yeah, I just received the final exam schedule, and I think that we will be doing it on campus. Correct? Wait, you like? I'm just kidding. I'm just kidding. Hold on a second. Let me double check that. Let me check that. Why? Why are you so scared of doing work? You don't want to see me at this one time. Hold on a second. Hold on a second. Let me double check that real quick. Okay, I'll be right back with you guys for like 2 minutes because I have the final exam schedule. Okay, just I just don't know if it was on campus or not. So let me just check them with you guys just in case. Okay. Oh my goodness. Wow. Yeah, it's amazing. Oh, okay. Wow. All right. This is the screen that I have so far. Okay, so this is all the people who are teaching the course, and it says online. Okay. I was so sad after I received the class schedule for the final thing because I really want to see you guys at least one time. I would like to see how you know how fast that you can finish the exam, or maybe how fast that you can fall into sleep during the classroom. So that would be awesome. No, I can't do that. I wish I could. The final exam is online. There's nothing to tell about that. Well, I definitely gonna need. Yeah, we're definitely gonna give you some extra time. Maybe if you could sing me like a happy birthday song, that would be awesome. But you didn't do that. Shame on you. I'm not gonna give you time for that. Lots of coffee. Yeah, yeah. I told you one story. Like I have a class. The final exam was given from 6 p.m. to 8 p.m. was like 2 hour class. I didn't really put down the number of hours for my student. So some people stay until 10 p.m. This is what I told you before. And then that person didn't really bring me dinner. He didn't really bring me a pillow, so I can't sleep over. Then, I at that time I had to take the train, and on the way back home, my wife just keep calling. What's happening? Where did you go? Did you talk to some girls? It was like seriously, I got stuck in class. If it's some people who basically fell to hand in the exam, I was like I wasn't really, you know serious about like what how many hours that he or she left. So people just sitting down, maybe eating some cookies, making me jealous. That's her last day. So they don't care about that though. But I do care because I really want to get home faster. And my wife is like, wow, come on, you gotta be home before 10. Where did you go? It was, I don't know what happened. There's no way I can make some excuse for that because the time is from 6 to 8. I was really got caught up. Anyhow, um, so that was pretty much this whole story that I had before. So sometimes it's not good to let people have the extra hours for that, like maybe 3 hours extra. Maybe 1 hour should be okay. Yeah, like Claudia asked for, which is perfectly cool. With some coffee as well. Yeah. I wish I could buy you a coffee for the final exam. And you'd be like, all right, so everybody comes. So I have to count how many cups do you need. Yeah. So I can make a coffee for you. So now I no longer become a professor. I've basically just like coffee maker. Hopefully that's gonna work. All right. 1 hours? Yeah, of course. So the final exam should be around an hour's. I'm sorry, no. You will be given like 3 hours on the exams, and I give you another half an hour to uh, take some screenshot or photos and upload it work on Blackboard. Okay, I think that that's gonna be fair. What is the date? That is a good question to ask. Um, so according to the syllabus, according to what I'm being told, the final exams should be taken on December 15th. Okay. All right. Yes. I believe it was official date for most of the classes, and that is the earliest date that we can have. Supposedly that we should take the final exams on December 20. But the fact is we don't have enough time for that. All right, so now my kids want me to go back to the room and do his work and do his homework. I was like, oh my goodness, it's really hard to do some kid homework, to be honest. Yeah, either 22nd or 29th. Yeah. I think that I'm gonna hold back to December 1st, okay? Because I look back to my chapter 11, and it was really crazy. 22nd? You want 22nd? Oh my goodness, I wish I could give you 22nd. Yeah, and then or either I will give you some review on 29 and then December 1st. Because when I look back to chapter 11, material was like, I got so scared with some of the calculation things. It was really difficult, especially when I don't have my magic calculator with me. You see what I'm saying? Because I uploaded, I can't use this on this computer. My wife wouldn't allow me to walk out of the house in a cold, lonely night. You know what's happening, so I couldn't really got into my sister's house to get my laptop real quick for that. Yes. So how many total exam are there? So there will be total 3 exams. I just want to make myself clear. The third exam that we just took, it was something that out of 100, and you're gonna add a 5 points from class work 1, 2, and 3. So to your exam grade, so you know how much that you got. And then the second exam will be taken, will be undecided, but I really want you guys to either take on 22nd or December 1st. But I will not want you to take on December 29th because I know there's a lot of things going on Black Fridays, Thanksgiving, Turkey, and then some party on Saturday, 27, and then 28, right? And then we might want to get back to the college on 29, and then December 1st should be a good day to take the exam. Yeah. And then after that, we're gonna have to go to one more chapter. So that should be on chapter 5 and 13. And then after that, we're gonna have some review on 13. And then the final exam should be done on December 15. Is that good, people? And then the final exam should be lasting until December 16th. So we have like 24-hour time frame to finish it. Oh, that's I don't know how to answer your question. Let's move on to another suffering chapter. Okay, that was chapter 11. I know it's if you ask me like if the final exam's hard, I would tell you this. It's as hard as cheating. No, I'm just kidding. All right, so I'm not gonna say it because my wife is here. It is as hard as drinking a cup of coffee, like hot coffee. Make it easy. Well, my questions was there. The true matter is the system is the person who picked the question. I shouldn't use the word person, but like the machine is going to pick the question for. Okay, I am not the one who decided which question that you get on the exam. It's departmental. Yeah, this is coming from the math department as well. And so to be completely honest, this math department for our class is actually gone on vacation for the semester. And she will be back next semester, so I can do whatever I want to. I'm just kidding. Usually I'm making my own final exams for 200 level. Usually we have the for 100 level that we should take the departmental final exam, but up to 200 level it was like graduate courses, like so I can make it my own final exam. So yeah, this is as good as much I can tell you. Okay, so let's go to chapter 11. I post some hypothesis concept. This is the question that I went through with one of the person from another class, and still math 213. And then that person asked me some question that he learned from biostatistics. It's like graduate courses as well. So he have a very deep knowledge on the hypothesis testing. And then, so that reason why I have to show them and then show you guys what it means by the hypothesis testing, the null hypothesis, and the alternative hypothesis. So I really don't want to like make this a very, very complicated chapter because the null hypothesis is something that we are trying to disprove, right? So we cannot prove anything about the hypothesis test, right? So the only thing that we can try to do is try to reject as many wrong things as possible so we can get a better picture of the population looks like. Okay. And then this is going to be the thing that you might want to read a little bit, but the whole sentence that I really want to emphasize is that generally the hypothesis testing revolves around a null hypothesis. This is the thing that we play around with, okay? The null hypothesis usually occupy very high percentage, should be around 95% confidence interval. But this is something that we try to get rid of. This is something that we try to disprove it from our statements, okay? And then, so that's pretty much the thing that I really want to show you guys what it is. To be completely honest, I haven't finished reading this. And the author, I think he's one of my colleagues also wrote out this papers generally. And however, if you're interested in knowing the hypothesis testing, so that should be great. You don't know, and then you just want to pass the class with a good grade. Let's move on to chapter 11. Okay, is that good, people? So now I want to introduce the chapter 11. So this is that chapter I would say one of the hardest chapter. The reason why it's hard because because it's involving this one. Yeah, have you seen that before? This crazy formulas. How does it feel, to have these formulas on the classwork or the homework problems? And the majority of the classes panic. I would say I taught this class 2 years ago actually, and let chapter 11 homework slide. I might add some points from chapter 11, so it's not gonna be something that we're gonna spend too much time working on it. Usually from the homework, I would add each person 5 to 6%, depending on how much points that you got from chapter 11 and chapter, I think chapter 2, there's a certain glitch on it on the SL file. We're gonna add some point as well. So look back to your grade book, and then we'll see what it is. And I still don't know like how some people got like 100 out of 100 from the homework at the start of semester. Within 2 weeks, I was so amazed, and yeah, it was really really tough. The reason why it's tough because, oh my goodness, I think I did this question a long time ago. Okay, the reason why it's tough because it's involving some hypothesis testing regarding two population. Okay, so what we're trying to do with for chapter 11 is no longer on a single population. So let me just tell you what it is. So the two populations, and very likely this type of question is going to give us two sample mean, two sample standard deviation, and they have to make the assumption such that the population variance are not equal to each other. And then we can utilize this fact to compare the average for the population. So this is the entire things that we have to know. So compare means of two population, okay? So in other words, we're going to have a big populations, and then we're going to have another population. So it generally, I'm going to draw two circle and two big jungle. And then the first one that we call big N, right? Big N, so I call N1. So the reason why we have N1 and 2 is just because we have two different population. And this is what we have for N2. And you can see that this is the new circle, right? I didn't really draw this exact same circle that we have earlier. And this is basically the new circle that we got right here. So this is what we have N2. Okay. And then after that, so this is the population ones and population two. Let me just put it down real quick. All right. And this is population two. Okay. And then after that, we can't compare the average. So the population one's going to give us the mean 1. Okay. And then the population 2 going to give us the mean 2. Okay. All right. So compared to those two, we're going to compute the sample, right? So we're gonna take out a few sample, correct? So we're gonna do the same thing. Sample 1, so we call N1 and N2, correct? So we have two sample. And then the first sample going to give us X bar and the standard deviation. I have really bad taste when I drawing out, when I put that in 1 and 2. So X bar 1, X bar 2, and S, okay? S1. All right, and then we're going to draw another sample of this population. Okay. And this is N2. All right, and so what's going on for that is we trying to compare the mean between these two population. Okay, we're trying to compare that, and basically we don't know the population standard deviation, so we cannot use the z-test. Okay, so if
the question based upon the sample standard deviation, then all we need to do is the fact that we're going to use the t, right? The t's test. So this is what we have. So before we can look up to the value for t, so we need to understand the whole purpose of comparing the mean of these two populations. If you only compare the mean without any differences, okay, I just want to check if the mean 1 is greater than mean 2. So that should be a lot easier. Okay, if we want to compare the mean, so this is on the HA, right? Such that the mean 1 minus or maybe minus mean 2. Okay, and that different from a certain numbers, okay? That different from 0, so you just want to test on a difference. If it's different from a certain value, we call it D, okay? And then that should be a different story. And then it's basically coming from the X-ray perspective, okay? So we have a lot of scenario, but one of the scenario is when we're testing on a different or when we're testing on the greater than. So you take mean 1 minus mean 2 is greater than the D. Okay, so this is another scenario that we might have. Okay, and then it's going to be less than a D. So the D's can be 0 if we only just compare them. But on the exam, I usually make the D equal to 0. Just don't want to give you like a lot of trouble with the D parts. Okay, and then the T test will be developed by. So we're going to looking at the difference of the mean 1 minus mean 2, correct? And then usually we have to assume that they have different variance or different standard deviation, okay? Different standard deviation or different variance. Okay, so the standard deviation and variance usually the same. So the variance is the standard deviation square, or in other words, when you take the square root of variance, so we're going to get a standard deviation. So usually that we cannot assume that they have the same standard deviation or the same variance most of the things. Okay, so when we assume that they have different variance, what happening is that they do not have the pool standard deviation when we compute it. And then the t-test, so we're just looking at the one sample t-test, and it was something that we have done before. I believe that most of us remember this formula is correct, so that'll be x bar minus, let me just do that again. Right, so I just want to let you know this one. So x bar minus the mean over the standard deviation. So standard deviation is S, right? So this is like a one sample, one populations, and then we multiply by radical n, correct? So we have learned before. Is that good? Right? And then actually the radical n is basically on the bottoms of the S, because that we call the standard error. The standard error that I explained before, it was the standard deviations of the sample average, like of a lot of data set that we have done it from chapter 8, correct? And then of course I do not want to remind you that suffering, I'm going to continue on 2 sample. Okay, the 2 sample t-test going to give us the t as well. And now instead of we going for the x bar, so we're going to have 2 x bar, right? We're going to have x bar 1, x bar 2, because we have to take a difference between the first population and second population. If you ask, does it matter? We put the second first and then the first later on. on the second part, it's going to be the same. We're just comparing the difference, and then D should be negative, right, along the way. So it doesn't matter about the position that we put down, x bar 1, x bar 2, but it's very likely I do not want to have some negative value. So I usually take a bigger number as x bar 1 and a small number as x bar 2. Okay, so this is 1 minus 2 for the sample. Oh my goodness, finally. I can draw something that looks okay after like 1,000 practice. And then, so we have to see if they have any difference. And then this difference going to apply on a sample. Remember, the unbiased estimates for the population average will be the sample average will be this guy, correct? And then it's also the unbiased estimates for the second population will be on x bar 2, right? And then we're going to do that by subtracting the D. Okay, usually the D equal to 0. If we only just compare which one is bigger, but I do not tell you how bigger that is, right? And then, and usually we see the node, we call it D0 instead of just put down D from the notes, and we divide it by the sample standard deviation, right? And then usually that we have to take the x bar 1 minus x bar 2 and subtract the mean 1 minus mean 2, right? And then the mean 1 minus mean 2 that we assume is just equal to D, right? So that's the reason why we don't subtract it by the mean 1 minus mean 2 from the population's population mean, because of the fact that, because if you subtract mean 1 minus mean 2, it's just basically subtracting by the D, because we assume that they have to be equal. Okay, and then that reason why we just put that minus D here instead we subtract the mean. Is that good, people? And then that we're going to divide it by S1 and S2 square and over N1 and N2. And if I have enough time, I'm definitely gonna go over the question from the classwork. I apologize, Chan is, she suggests that if I can go over it, the answer is absolutely yes. Just let me finish it. I do one practice and we're gonna come back to this chapter on Wednesday. And then I would definitely going to go over the question. You know, sometimes I just keep talking and just sort of like forgot what I'm doing. Class and so on and so forth. So I do apologize for any inconvenience. And so remember, so why we have like S1 squared, because when we have the square root and then the squared is going to be canceled, this is what we call the, you know, the standard error for two sample. Okay, it's sort of the same thing like S. So you can, if you take the S square over N, right? And then we take the square root, it's basically this one. Right, S over radical N, okay? It should just mean the same now, but we have like two variants, and then we have to do that for the question. So we divide it by N2. Is that good? Okay. So I would say this is not really complicated calculation, because all we need to do is just based on the one sample. Usually when how I can memorize the formula, just use the one sample formulas, and then I just changing, instead of we taking the x bar, just taking a difference by x1 bar minus x2 bar and subtracting mean, just subtract a difference if there's nothing to subtract, and then the D equal to 0. And then we're gonna divide it by the, you know, the variance of, I'm sorry, the standard error of two sample, and then we're gonna got this part done. Is that good? So this is going to be something that we will use on the exam. Okay. Okay, so again, that realistically speaking, this population standard deviation usually are not known. If you knew what it is, then we should not continue on the average, right? Because in order to compute the standard deviation that we need the average, if the average is not known because they don't have the data set, how is that possible? We can know the population standard deviation for for this two population, correct? So, and then we cannot treat them as the equal because, yeah, we're gonna get back to it. I'm gonna get back to you for the DF. It's DF is really hard to write. Okay, so it's gonna be assumed equal, and because very likely you can't find two data sets that have exactly the same population standard deviation, or the population standard deviation not going to make a lot of difference. Usually that they have a lot of differences, unless that you're going to just test out one population and another population, and the time zone is very close. You're going to test on the same thing, but this technicality doesn't work. Usually that in order to make this work, we have to assume that the population from two sample are independent. Okay, this is the most important perspective. If they're not independent, then we cannot use this formula. And generally, how the heck that is possible? I can find two populations, they are independent of each other. And it's really, really hard to find that. Okay, so so this is the theoretical assumption, and it worked out for some population that are most likely irrelevant to each other. So let's say I want to test on my third exam of Math 213 and my final exam of my sociology, or maybe I want to test on my third exams of Math 213 and my SAT score that I took a long time ago. So usually those are not having a lot of dependent factors. So meaning that we can use this competition for the analysis. Other than that, if you just test on exam one, exam two, and of course they are highly correlated, it's not going to be working out really well along the way. So the value of the t-test depends on the x1 bar minus x2 bar. So the d0, if the different, we just only compare the mean without assuming any difference. So this one would be equal to 0. Okay, is that great, people? And very likely, I might give you d equal to 0. So we just, let's say I want to compare the average salary of one person, of one group to another group, for instance. And then I just want to see which one is higher. I don't tell you exactly how much higher of one group to another. So we have to assume that d equal to 0. Okay, so this is just the formulas that we have for the d, for the t. So the thing is, when we compute the degree of freedom, it's gonna be a different story for that. So the degree of freedoms will be computed by this formula. So what do you think about this one? Would you be able to get that done like completely? So when you compute the degree of freedom, so that would be S1 square over N1 plus S2 square over N2, and then you do the square on top, and then you divide it by S1 square over N1 square over N minus 1 plus S2 square over N2 square over N2 minus 1. Okay, if you are a calculator expert, I suggest that you can try this calculation in a single calculator and just try this on a single calculation and see if you can work this out. This calculations is one of the toughest calculation that we have, and actually the worst in our class, okay? Because in order to compute the degree of freedom, then we have to do like some small part of calculations on the top and the bottom. Is that good? So the degree of freedom is, this is not a pair degree of freedom for two population. So that reason why we end up getting something really, really crazy. Okay, so so this competition can be done on GoGo's or on a calculator. So I don't have a calculator with you, but on Wednesday I will show you on GoGo. I'm sorry, I will show you on it. But today I will show you how to do this calculation on GoGo. Is that good? So we're going to deal with this calculation in the following example. Okay, let's try to do it for that one. For that one. Okay. And I might give you this question on the exam just in case. And again, that it's become a very important chapter. Let me just go over it. All right, so this is going to be the questions, right? And then what we are trying to do with, we're trying to compare the easy fund and the difficult fund, right? With the sample equal to 10 and the X bar were respectively equal to 8.23 and 15.10. And then the sample standard deviation was 5.61 and 9.28, right? On the exam, you can't just tell me that, well, I can see the X bar, they're drastically different. And there's no argue about that. Such that, and then the sample is relatively small. And then you can't just say that, well, it's have to be true. But you have to show me work, because if we have a really big standard deviation, there's no way that we can say that the difference between 15.1 and 8.23 matters. Remember, those two just the sample average, right? So the decision we're making will be on the population average. Okay, so the first thing that we need to do, just write of the hypothesis. The first hypothesis going to be on the equal, right? So this is what I said earlier. I'm going to put in down the mean 1 minus mean 2. In this case, I try to avoid the the negative parts. I just don't like negative numbers, to be honest. So that's the reason why I'm going to put that mean 2 minus mean 1, or different from mean 1. Okay, so it should be the same thing. Oh my goodness, I have a lot of trouble writing number 2 on this things. Minus mean 1 different from 0. Okay, is that good? No, it should be equal to 0. Did no hypothesis have to be equal? Okay, is that good? And then you can't just put mean 2 equal to mean 1. That's perfectly okay. It doesn't matter. Okay, you can just put that. You can just put down the mean 2 equal to the mean 1. So I believe it's going to be the same notation for that reason. Okay, on the bottom, so we're going to test if the mean 2 is less than, right? I'm sorry, greater than. I apologize. So even though the keyword for that was less than, but I was trying to look for positive numbers, so I just put greater than. But I think you can do less than, doesn't matter. So I just don't want to go against the questions, right? Because we see the keyword was greater than, so you might get some negative value for the t. We just use the left tail area, so that should be cool. Okay, so I just changing it. So mean 2 minus mean 1 instead of, I'm sorry, mean 1 minus mean 2. Okay, so let me just put it down real quick. Okay, it's just making no difference. Like if you test 1 less than 2, it's going to be the same as 2 greater than 1 for that reason. Okay, are we good with that? Is that good? So I would call this is N1 and this is N2, right? And this is N2. All right. It should be less than because the X bar 1 is less than X bar 2. All right. So the next step that we're going to compute the t-score, right? The t-score according to the forms. I'm not gonna write the form for that, right? And it should be x1 bar. So x1 bar that we have is 8.23 minus x2 bar 15.1. Is that good? And we have to subtract it different, all right? But the question doesn't tell us how much different from the easy to read font to the printed to difficult to read font. If the question says like 5 point, 5 point less than the the difficult font, so that should be -5, okay? But the question doesn't tell us 5 less than that. The question just say was less when the instruction was printed. So there's no numbers before less or after less. So there's no value that we take into account for D. So D has to be equal to 0, okay? So you don't have to put anything here. You don't have to say mean1 minus mean2 less than 0. Just put mean1 less than mean2. That's completely understandable. So now we're going to divide it by, again, I do not want to write that phone. It's going to take me forever to do that, especially on this computer. So what I'm going to do was I'm going to take the square root of S1 square over S2 square. Remember the S1 that we have from the questions? It was 5.61 and 9.28. Okay, just want to make sure that we know this one. So I'm going to take 5.61 and square. Okay, and then the N1 is equal to N2, so that was equal to 10. Oh my goodness, I don't know how to get rid of this, but this is actually one of the final exams questions from the math department. And plus, so 9.28. They have relatively big standard deviation. So 9.28. Okay, and then of course we're going to put the square on top. So let me just fix this line a little bit. Okay. And then let me just draw it better. All right. And then we divide it by N2. So N2 also equal to 10, right? The N1 equals 10, N2 equals 10. So we're gonna do it on the calculators. Okay, is that good, people? Now I'm gonna show you how to do it in GoGo. I know that most of you might be a little bit eager how to do that in a single calculation. So we take 8.23 minus, can somebody help me do that? 15.1 over the square root of 5.61 square over 10 plus, so I don't need the parentheses for that because the GoGo calculator is going to understand that I'm going to do the square for 5.61 plus 10. I have the parentheses in the front of the square root, so the calculator should be able to understand it. And then, so we're gonna take 9.28 square over 10 as well. Is that good? Is that too hard? Yes. Now you guys are making me so proud. My goodness. I taught this chapter, it took me 2 hours, like 2 hours for one single topic. Like how to do this on the calculators on GoGo. And then you can definitely gonna check, how many parentheses should I put that? You are in computer science major and you just need like 2 brackets, okay? 2 parentheses for that. The first one is basically on numerators when you take the difference. And the second one is basically for the square root. Out of that, we just have to do exactly the same thing as we have done here, right? And then I'm going to copy this calculation just in case that we don't know how to do it. And then the answer for that is negative 2.0. And let me just copy that part real quick. And I believe it's very valuable for you guys and how to compute this on the exams, right? And then I would say this is what we call global forms. Google calculators. And you'd be like, wow, you depend on Google too much. Where's your calculator? I'd be like, I couldn't afford it. The cost was so cheap. They couldn't really give me a better calculator, better than TI-83. Yeah, I mean, you can get any calculator for that reason. So now we're going to compute the degree of freedom. So this is going to be another story for that, right? So the degree of freedom is going to be something that we have such a hard time to do it. And then this is what we're going to plug that in, right? And then, I mean, the only thing that makes the chapter 11 different from chapter 10 is the fact that we're going to do with 2 sample, and then the calculations just become a little harder when we look at the t values and the degree of freedom. So now we're going to plug in all of these values at once, okay? So first of all, that we're going to have the S1 square. Oh my goodness, whenever I do this calculation, that's going to take me a long time to put this down. So we're going to get 5.61 square. Okay. Over M1. So the M1 that we have is 10. So we divide it by 10 plus, so S2 was 9.28 square. Over 10. Oh, how many of you got this? Let me just double check that. Yeah, it's very, I think so. It should be like less than N1 plus N2 minus 2. Yeah, it should be less than that. Yeah, it should be 14.8, something like that. How did you do that though? Did you break it down in terms of multiple calculation or something like that? Or just do it once? If you can do it once, you're super good at it. Oh, you do the top first? Oh, nice, very nice. Okay, yeah. Then the bottom, that makes sense. Yeah. And then I'm going to do S1 square. So S1 was 5.61 square, square over M1, and then have a square as well. I think I just copied out this part, and I feel like it's a little easier to deal with. Okay. Square. Can I do square here? Maybe over M1, which is 10 square. Actually, I don't have enough space for that, so I have to make this smaller. Okay. And then, so we have a square, and then square, and then over 9, because we have the M1 equal to 10 minus 1 is 9. And then on the other side, we're going to do the same thing, plus 9.28 over 10, and then square, and of course we have a square in here, and then we divide it by 9 as well. At least I'm going to be like the calculator trainer, and you might not learn anything after class, but you will be able to use the calculator pretty well and pretty proficient. And then we're gonna do these calculations, okay? And the first thing that we need to do, I mean, we can combine them. It doesn't matter. It's for numerator and denominator, but according to Victoria's perspective, that we can just compute it by the top. So 5.61, 61 square over 10 square, right? Plus, no, over 10s, and that's it, right? We don't have a square here. Plus 9.28 square over 10 and square this part. Okay, so we're gonna get around 138.27. Is that good, people? 138.27. Yes, it's pretty hard, right? It's pretty hard, but it's not that hard. Just break it down a little bit. 1150, 1138.27. Right? And then the second calculators. So I'm gonna use Google one more time. So I don't want to mess that up. I want to take 5.61 square over 9 over 10 square over 9 plus, right? And then we're gonna have this 9.28 square over 10 square over 9, right? And I got this is just 9.34. Is that good? Okay, and then this is 9.34. And then we just do that division. Oh my goodness, this calculation take me 5 minutes. Shame, what a shame. So we take 138.27 over 9.34. It was 14.8. Is that good, people? And then we just add up to 15 for that reason. All right, is that good? Any concern for that? Any questions? Yeah, that is the hardest part. If you forgot how to do it, I would take away 3 points, 2 or 3 points on the exam. It just to put out, I don't know, not gonna lie, this is really hard. And then and then it just use some degree of, I can tell you that this one, the degree of freedom, the df should be less than n1 plus n2 minus 2. It's just like less than combining the degree of freedoms. This is the pool degree of freedom, and it should be less than 18, right? Because 10 plus 10 minus 2 is 18. So if you compute something that is greater than 18, that should be the wrong answers. Okay, so the degree of freedom should be less than 18, and then you sort of should be bounded between 10 and 18. Well, I don't know how to compute it. I just picked any of them. All right, that makes sense. I got 1,000 something. That is something that we're going to. Let me just copy down a calculation real quick, and then I will just continue on the things. I know this one is really complicated, and it's not quite easy to get to the final answers correctly. We have to break down things, and of course, I know that maybe you might have some trouble with some of the finger typing skill, something like that. But you have no trouble typing to your best friend, to your partners, to your boyfriend and girlfriend, right? So I would say we just look at these questions, feel like, well, this is going to be, my dear, partners, and then I really don't want to mess that up. And then you definitely gonna get it right. For that reason, I guarantee you 100%, treat these questions as your life partner. Trust me, right? I think that most of you might have established friendship on Discord or on WhatsApp or something like that. At the end of the day, you might not know me at all because I don't see each other at least one time. But definitely, this is going to be something that you have fun with. Just treat this as your friend, and then just compute it, and you might be able to get it done. And then this is divided. Okay, and then sometimes I'm just too lazy to do for this calculation. I just combine this, and then I open and close parentheses. I can usually get it into like a single calculation, but it might be really, really challenging to do so. Oh my goodness, I would get 14.8. Yeah, you can see that all of this can be done in a single calculation. Is that cool? You may not like this question, trust me. It's just something that, yeah. I'm not trying to train you guys to become like, the typer for the calculator, whatever it is, but it's really cool. We can combine them. Usually I show them on the TI-83 for a single calculator. So you might mess up the things, but just type in, open the parentheses for that. And then square, remember after the square, you don't need the parentheses, just divide it by 10, and then plus 9.28 square over 10, and then make sure that you're gonna put the square root, and then you're gonna get the answers, which is 138.27. And after that in the bottom, so you gotta be careful with this. So you need the parentheses before the square of that, and then you just have to do 5.61 square over 10. And then you have to do that. You have to open close parenthesis square, such that we have to do the whole thing first before we can take the square over 9. And then we do the same thing on the other side. And it should be what you get the final answers correctly. It's done for the day. He's really had it. All right. And then I have people who said, like, this calculation was is too tragic. I just put, not gonna lie, just CMM and call my mom is after this question. I'll take 3-point loss. 3 points loss. Yeah. I mean, sometimes we suffer the loss just to make yourself happy for that though. And okay. All right. I mean, if you can't treat this chapter as your friend, at least you're gonna say something nice. I'm gonna consider it just taking 2 points instead of 3 points. I'm just kidding. Some people might do something like that. It's really cool because I do not know exactly what the value of the DF because the calculation was so messy, but I do expect that the degree of freedom should be less than 18, less than M1 plus M2 minus 2, should be less than 18. So I would try to take like 16 or 17. Is that good? Oh my, if you write something like that on the exam, you're like cracking up. Anyhow, so now after we get the degree of freedom, so the next step that we go into, basically we apply the same strategy for that, right? We're going to, oh really? Yeah, we have to write it down. The reason behind that, because every single test, every single chart, every single table, we always use like something smaller with the degree of freedom because that's going to give you that's going to give us the safer bow, the safer critical judgment when we consider either we reject or we accept the alternative hypothesis. So if you take 15, I give you full credit for that, but most likely, and even on the table number 4 that I give out is always ask you to route down the degree of freedom to 14. Okay. Yeah. So you can literally check for very small letters. Sometimes we have to use some sunglasses, some magnifier to zoom in a little bit. So for degree of freedom is not found, we always use smaller. Yeah, you're absolutely correct for that reason. But if you do bigger, like 15, that's perfectly cool. Okay, it's yeah. I'm so sorry about that. But you can use either 14 or 15. But officially speaking, to be completely honest, it's have to be equal to 14. Okay. Would you forgive me for that? So I forgot it. Oh, come on. You are so harsh on me. Now I grade your exams. You know how I felt. I'm just kidding. I'm just kidding. All right. So 14 always have to, sometimes we call it route down for degree of freedom, but it doesn't matter when it do the exam. I know your homework is not your friends, okay? When they grade you, they want you to do exactly what they ask us to do, okay, to deal with. So whenever, even if you have some decimal numbers, always be safe that we're gonna take that 1 degree of freedom. So that'll be 14 instead of 15, okay? And after that, The questions also use the alpha equal to 10%, right? So the alpha equal to 10% in this case. Okay, the alpha 10%. And then this is also one tail, correct? Yes, always route down for degree of freedom for this chapter only. And let's pray that the homework is not going to take away points. Of course, I would not really, when I grade your exam, it doesn't matter to me that much. If you route up, I give you full credit. If you route down, I give you full credit. But if you don't know how to compute it, then of course I have to take away points. But again, that it's not all about this chapter. This is also the thing that we're going to write the hypothesis correctly, and then how to compute the t correctly. And then the degree of freedom is just one part of it, so it's not going to be like worth a lot of points. Okay, teamwork, oh, come on. And then now we're going to go for the degree of freedoms and the alpha equal to 10%. And then we're going to go for one tail area. So let me just copy this real quick for that. All right, almost done. I know this chapter was really, really challenging for not only for you, but also for my Google calculators. Okay, and then we're gonna go for 14 degree of freedoms. So yeah, if you passed my class, you're definitely gonna pass every statistic course. Only for applied statistics, you haven't seen something really crazy. Like proving this one wasn't as bad as proving the central limit theorem. The central limit was really hard to prove. This one was we just playing around with numbers. Oh, too bad. I know, Victoria. You're always proud of yourself to be bio major, and then you can just show me like how fast you can do all of this math. Oh my goodness, yeah. But just be mercy a little bit, right? We're still like learning all of this stuff together. Oh, nurse, I'm so sorry. I keep forgetting on your major. I'm so sorry. Would you forget me on this time as well? Oh, come on. This is, yeah, sometimes we have biology. I thought your bio majors is really good, the biotech. Okay, forgiven one more time. So I appreciate it. So we're gonna go for a one tail area. So we have the t equal to 1.345. Yeah. She forgive me a lot of time. So we're gonna have a TC equal to 1.345. Is that good, people? Can I do it at once here? Or if you don't like this, I can just do it on the other page. Just want to make sure that we understand. So the TC that we got is from the last page was 1.345. Okay. So now, which one is bigger? Yes, because we have to take a negative side because it's on the left tail. And then remember when you compute a step number 2 that we have -2. And then when we compute this one, we have to keep a negative sign in front of it. And this is -1.345. So now when we take the absolute value, so we have the t basically greater than the tc. Is that good? Right? And then it means that we're going to accept xj. Any concern for that? Any question? Why it is negative? So the whole reason behind that, because the whole reason why, let me just put it out. We need negative for TC, right? Negative because of what? Somebody can explain, help me explain. Of course, I know your names because we compute from t equal to -2, right? It's on the left tail. The left tails, you always have to look at to the left, meaning that we also have to use the left side areas. Okay, yes. So, and if you don't want to do it that way, I feel like this is the easiest way we can do it, right? So when the t's in the amplitude is greater than the tc, then we have to accept xj, and if the t less than tc, then we're gonna reject xj. So I feel like that's the easiest way that we can make that decision. But if you don't like that, so we're going to draw the entire mountain one more time. And you're very welcome. So yes, please ask question. And then that we're going to put this down as, remember, the testing region have to be started with TC, not the other way around, because statistics going to be whether or not we're going to identify the region where the T belong to, right? So the TC is always be the thing that we're gonna put some marks on, right? And then, so this is going to be the thing that we put here. And then -2 was something that is on the here, right? So it's gonna, so it's basically on the accepting XJ regions, and then we're going to say that we accept XJ. Any concern for that? Any question? Any concern? I mean, you don't necessarily have to do that on the exam. We just say T greater than TC, then we're gonna accept XJ, and that's pretty much it. But if you want to draw out the pictures, so we're gonna get what it is here. Any questions? So the hardest part, again, that we're gonna be computing the degree of freedom, that one's is really tough and challenging. Okay, but according to Gogo, we can just break it down in terms of numerators and denominators, okay? Or we can do it once, but it's gonna be a lot of work, okay? So I would definitely gonna go over chapter 10 classwork, I'm sorry, from the classwork, and then I would go one more example, and after that, we move on to the next topic, okay? So I know it's chapter 11 was very complicated and very difficult. So this is going to be your suffering chapter, but bear with me, okay? If you get this done, you are comfortable with the calculators, with the calculation, you should be great, okay? So I believe it's overtime. I should let you out a little early for that, but remember the times that we have is almost the end of the lectures. So I hope that you're gonna forgive me for some mistake that in May, especially something that we have the routing stuff. Okay. Oh come on! I haven't really started taking attendance. You guys were so quick. Oh my goodness! I only call your names once, of course. I don't even call your name. I just like copy your tech chat, and people just, oh my goodness, and leave right away. Oh, what a shame! And don't call your name try because I would get track of it. Yeah, I might put you late because you type twice. You're gonna hurt my eyes on the screen. Anyhow, all right. So thank you so much for your participation. Oh, I wish you guys like everybody comes to the class. Why we only have like 39 people, and I wish 44. I just put presents here without looking at it. All right. But anyhow, so thank you so much for tonight, and you guys just make this chapter my day. To be honest, I never taught a class that without a lot of suffering like this. Every single time I taught this chapter, that people always have some problem with the calculators or the problem with the calculation. But I appreciate it. I hope that you're gonna enjoy your night and then have a good sleep and not let this calculation haunt you like in your head and your mind, so on and so forth. And I hope that you guys are going to have a good day, have a good night, and I'll see you guys back on Wednesday. Take care.